All right, so what we're doing today is simplifying radicals, which is a review. You've done almost everything that we're doing today. And then we're going to talk about solving quadratics using a square root. Okay? So I'm going to be moving relatively quickly because 90% of this is review. You've done it, spent a lot of time on it. I don't want to waste your time or mine. Okay? But that being said, if you have a question, please stop me and I'll be happy to explain what's going on. Okay? So let's start with number 1. It says, what two integers is each radical between? What does the word integer mean? Okay, whole numbers that are positive or negative. So what two integers is the square root of 67 between? Okay, and how do you know that? Good, so it's in between the square root of 64 and the square root of 81, which means it's in between the integer 8 and 9.
Why don't we write it squared, though?
Because the square root of 67 is the value between 8 and 9.
I see.
Okay, what about negative square root of 20? Negative 5 and negative 4. So it's greater than the opposite of the square root of 25, but it's less than the opposite of the square root of 16. So it's between negative 5 and negative 4. On your homework tonight, numbers 18 and 20, it says round to the nearest 10. Well, I'm not interested in you being able to type this in your calculator. It's a waste of time. Okay? I'd rather you tell me what two integers it's between. That's a good approximation for you to think about. Okay? All right, let's review simplifying radicals. So if you'll remember, when we have the square root of 20, we break it down into its prime factors. And then the ones that repeat, the ones that are squared, we take the square root of those and pull them out. Okay? So I make something like a factor tree where I kind of just go down with all my factors. You might do something a little different, and that's okay. Do whatever you remember. Okay? So how do I break down 20? 4 and 5, 2 and 10. Does it matter what you use? No, you're going to get to the same place each time. So 4 and 5 and 2 and 2. Okay, so notice we've got 2 and 2. We've got a pair. So the square root of 2 times 2 is what? It's just 2. So 2 comes to the outside. What gets left under our square root? 5. You remember this part?
Yep.
Okay. I'm going to skip B and C for a moment. Let's look at D. 6 root 30. So let's start by breaking down the 30. 6 and 5. And then 2 and 3. Are those all prime?
Yeah.
Yeah. So I have to stop. So does the square root of 30 simplify? No. So this is just your answer. It's already fully simplified.
Would that be direct prime?
No, you're not going to write prime. That's kind of a different topic. Okay, look at E. 2/3 times the square root of 48. So let's break down 48. Give me two numbers. 4 and 12. Okay, so 2 and 2. 3 and 4. And 2 and 2. So we have 2 pairs this time, right?
Yep.
So when we pull them out, what do we do with those values?
Multiply 4.
Multiply them. So the 2/3 is already on the outside. I also get a 2 on the outside from this pair. And I get a 2 on the outside from this pair, right? And what's left on the inside? Root 3. What do I do with these 3 numbers? Okay, so 2/3 times 2 times 2 is going to be
8/3.
8/3 root 3.
We have a test that we just did.
All right, the square root of x to the 7th. What I want you to do is I want you to write this out and expand it. So this is x times x times x times x times x times x. Wouldn't you agree? 1, 2, 3, 4, 5, 6, 7. Wouldn't you agree that that's the factorization of x to the 7th?
Yeah.
Those are the way we get to multiply. So let's look for our pairs there. How many pairs do we have?
3.
3. Right there, right there, and right there. So each of these pairs sends one x outside the radical, right? So on the outside we have x times x times x. Remember that it's multiplied because that's what we do with numbers on the outside. What's left on the inside? Just an x. What is x times x times x?
X cubed.
So it's x cubed root x. Oh, sorry. Root x. That's weird because I said root x, but root 3. You okay? All right, look at the next one. 2x squared times the square root of 12, x to the 4th, y cubed. Okay? Now, this is just the same thing, just basically a lot of them pushed together, right? So if it helps you, it kind of helps me to rewrite this as 2x cubed times the square root of 12 times the square root of x to the 4th times the square root of y cubed. If that makes it more challenging, then don't worry about it. But if that helps you to visualize it, you can break it up that way. Okay? Because we've got to take each piece individually.
Can you break it up further? Like with the x's and the y's?
Yeah, so now we're going to start simplifying it, each piece. Okay? So let's simplify square root of 12. 12 is 4 times 3. So that's 2 and 2, which is our pair. So would you agree that this stays on the outside?
Yeah.
Okay? So this is 2x cubed. What comes out from here?
2.
Times 2. And what gets left under my radical?
3.
3. Okay? X to the 4th. That's x times x times x times x. So how many pairs do we have? 2. So when we pull out 2 x's, and those get multiplied, so what do I have?
X times X.
X times x, which is x squared. Do I have anything left under the radical?
No.
No. Okay, y cubed is y times y times y. Pull out a y. What's left under the radical? Y. Okay, now we can't leave our answer like this though, can we?
No.
So we're going to take all the stuff on the outside and multiply it, and all the stuff on the inside and multiply it. Okay. So we've got here 2 times 2, which is 4. X cubed times x squared, x to the 5th. And then I don't have anything left to multiply y by, so just times y. Times the square root of what's left under my radicals?
3y.
3y. Okay? Questions? All right. So, just like we did there, when we multiply radicals, we multiply the outsides and we multiply the insides. Okay? So, 3 is 3 root 10 times the square root of 5. So we're going to multiply the numbers on the outsides. So 3 times essentially 1, right? 3 times 1 is 3. And then on the insides, I'm going to have 5 times 10. Now you can absolutely write it as 50. But we have to simplify it from here, right? So to me, it's easier to simplify smaller numbers. So if I just write it as a product, I've got smaller numbers to deal with. Y'all see that? But if you want to write it as 50, that's fine. So I have 5 times 10, which is really 5 times 2, right? So now what do you see? I have a pair of 5s. So 1 5 comes out, and we get 15 radical 2. Okay? 4 root 6 times negative 3 root 15. Multiply the outsides. Negative 12. And the insides, I'm going to leave it as 6 times 15. All right, let's break down 6. 2 and 3. 15. 5 and 3. And what do we have? A pair of 3s. So the 3 comes out, and what do we have to multiply it by? The negative 12. So it's going to be negative 36 root 10. We okay with that? So if we try and break 10 out, down, it's going to be 2 and 5, which gives us no pairs, so we can't take anything out. All right, let's talk about dividing radicals. When it comes to dividing radicals, here's the important thing to remember. Okay? The square root of A over B is exactly the same as the square root of A over the square root of B. Those are exactly the same. So you've just got to kind of figure out what is better for your particular problem. It's not really a formula to memorize. It's just a property to know so that you can simplify radicals. Okay, so the square root of 25 over 36. This is one of those where, to me, it makes sense to split them, right? I can write this as the square root of 25 over the square root of 36. What is the square root of 25?
5.
Over what?
6.
6.
We don't need to put it back on the square. No.
All right, the square root of 27 over the square root of 3. How do you think I should rewrite this one? Yeah. Go ahead and expand your square root so it covers everything, because why would I want to do that? Why does that help me?
Because then you can divide inside of it.
Yeah, because what is 27 over 3?
9, which is
9.
3.
And so now I've got the square root of 9, which is 3. So you've just got to kind of consider the values you're given and decide which way you want to set it up. Okay, look at number 7. The square root of 27 over 3. Now, I can't expand that square root because it's not already over the 3. I can't just make it be over the 3. So what do you think I have to do first?
Multiply 3 by 20.
Yeah, let's simplify the square root of 27. So I've got the square root of 27, which is 9 times 3, 3 times 3.
Pair of 3.
So what do we get?
Pair of 3s.
3 radical 3
Oh.
over 3. Am I allowed to cancel numbers outside the radical?
Yes, yes.
Yeah.
Yes, yes, yes.
If they're outside the radical, I can. So 3 over 3 is just 1, so I get
Radical root 3.
root 3. Questions on this? Okay. Let's... Oh, yeah, sorry, Sean.
So could you multiply, like, square 3 and then put a square root around it and then proceed to do, like, everything else?
Why do you want to die?
Yeah, that hasn't caused any problems if you square something and square root it at the same time, because it gives it back to the original. Is there another question? Okay. So, in order to be fully simplified, you must not have a square root in the denominator. Okay? Remember that if you do have a square root in the denominator, you have to do something called rationalizing the denominator, which means we multiply the top and the bottom by that radical so we can get it to cancel out. Okay? And that process, again, is called rationalizing the denominator. Look at number 8. 1 over root 3. What's the problem?
There's radical 3 in the denominator.
Yeah, we have a radical 3 in the denominator, so we've got to get rid of it. So we're going to multiply the top and the bottom by root 3. The reason I refer to this as a fancy version of 1, as a fancy 1 I call it, is, wouldn't you agree that root 3 over root 3 is just 1? Yeah, because it's something over itself. That's why I'm allowed to do this. So I'm multiplying by 1. And multiplying anything by 1 doesn't change it. Okay? So now we multiply across the top and across the bottom. So 1 times root 3 is root 3. Root 3 times root 3?
3.
Yeah, it's 3. Yeah, you should have done this before.
We did it in geometry.
I'm pretty sure you do it in geometry.
We did it in algebra 1 also.
Hmm?
I remember doing this in
Wherever.
wait, no, that was practice.
Okay, everyone okay with that?
Mm-hmm.
All right. What should we do in number 9? We've got 4 root 6 over 3 root 5. Yeah, multiply top and bottom by radical 5. Okay, so multiply across the top. 4 root 6 times root 5 is going to be 4 root 30 over root 5 times root 5
15.
is 5 times 3, 15. Does radical 30 simplify? No, because it's going to end up being 2 times 3 times 5. Which doesn't go anywhere. My 4 and my 15 don't simplify, but if they were values that did, could I reduce here?
Yes.
Yes.
So that's
Okay.
Like if that 4 was a 3, would you change it like this?
Uh-huh. Okay, look at 10. This might be something a little bit new, and we'll keep practicing with it. Notice in here, this was 3 times root 5, so it's easier to get rid of. Here in the denominator, we have 3 plus root 2, so we have to figure out a way to get rid of that plus root 2. If we tried, don't write this down. Okay, just watch. Don't write this down, though, because I don't want you to write the wrong thing down. If I tried to just multiply by root 2 over root 2, I'd get 5 root 2 over, I would have to distribute this 3. So I would get 3 root 2 plus 2. So I still have that root 2 in the denominator. Okay? So we can't use that process. Instead, what we're going to use is something called the conjugate. Okay? Something called the conjugate. And we're going to multiply the top and the bottom by the conjugate of my denominator. And the conjugate of my denominator is 3 minus root 2. You switch the sign in the middle. This is called the conjugate. And in just a sec, once we multiply it, you're going to see why we did that. You're going to see why it works. Okay? Switch the sign in the middle. Okay. Put parentheses. Okay? Let's distribute our 5. 5 times 3. 5 times negative root 2.
negative 5 root 2.
Good. Okay, now let's distribute our 3. 3 times 3. 3 times negative root 2. Negative 3 root 2. Okay, now distribute this root 2. Root 2 times 3 plus 3 root 2. And root 2 times negative root 2. Negative 2. Good. Okay, so I hear a lot of ahas. What are you noticing? Yeah, that middle cancels out. What I want you to notice is that I've now utilized our rule a plus b times a minus b. A plus b times a minus b gives us a squared, 3 squared is 9, minus root 2 squared. which is 2. Okay, that's why I use the conjugate to cancel it out. So I'm left with 15 minus 5 root 2 over, what's 9 minus 2? 7.
Are you recording?
Wouldn't it be 10?
Oh, can you not subtract?
No, because the 5 is like
Oh, because
attached.
they're different variables. No, because like, right.
I didn't see it.
Oh, never mind.
It is, but that's not plugged in, but I'm still recording. Sorry, was there a question? You okay?
Yeah,
I just said, wouldn't it be 10 radical 2?
Nope. As we're going to see in the next slide, remember that you can only add and subtract radicals if the radicands match. Okay? All right, so that takes us into our next step of adding and subtracting radicals. Can only do it when the number under the radicals match, when the radicands match. So I've got 5 root 2 minus 7 root 2. Can I subtract those?
Yes.
And what would I get?
Negative 2 radical 2.
Negative 2 root 2. All right, look at the next one. 3 root 5 plus root 20. What do I have to do to that before I can decide?
Simplify 20.
Yeah, simplify 20. So this is 4 times 5, which is 2 times 2. So I have a set of 2s, so I get 3 root 5 plus what? 2 root 5, which gives us
5 root 5.
5 root 5. Okay, look at number, do we have time?
No.
Yes, we do.
What time did we get?
Okay, look at number 13. You know, if you guys hadn't said anything, I might have skipped it. All right.
We completely have time.
Nope, too late. All right, negative 3x. But you will need to watch the video. It's different than this. Okay. All right, hey, shh. Negative 3x times the square root of 16xy squared minus 2y times the square root of x cubed.
Could you get rid of the, change to 16xy because it was like the square root.
So we're going to simplify each square root so that we can see if we've got radicals that we can add. So, hey, gentlemen, stop talking. Thank you. So I've got negative 3x times the square root of 16xy squared. So let's simplify that. So I've got negative 3x. What's the square root of 16? So 4 goes on the outside. What's the square root of x? It just has to stay in there, right? So x stays on the inside. What about y squared?
Y.
Y comes out. So this is negative 12 xy root x. Okay? X cubed is x times x times x. So what can come out?
Take an x out.
X out. So this is minus 2y times x. What's left under the radical? X. So I have minus 2xy root x. Now can I subtract those?
Yep.
Yeah, and what do we get?
Negative 14 x y. 14 x y.
Good job. Okay?
Yep. I got it.
The outside doesn't necessarily have to be the same, but if these weren't like terms that you could add or subtract, you would have to kind of write it like 2x minus 4y parentheses root x or something like that. Yeah.
In the first, like the first part of that, why does the y come out of the radical?
This one?
No, the first one.
This one?
Yeah.
Because y squared breaks up into y times y, which is a pair, and so 1 comes out. Okay?
Get it.
All right. Solving quadratics. When there's
Guys.
no b term, you can use square roots to solve for your variable. Okay? And remember, b is that middle term, like 5x in the middle. So when there's no b term, isolate x squared, and then you can take the square root of both sides. So number 14, it says x squared minus 25 equals 0. So I want to start by isolating my x squared. So what am I going to do? Okay. So I get x squared equals 25. What do you do to both sides now? Take the square root. Now when I myself add in the square root, do you remember what I told you have to add in as well? When you are the one that writes in the square root, yes, you have to remember to put in plus or minus. Okay? You can't forget that because remember, most of our quadratics have two solutions. We need that plus or minus to give us the two solutions. So this means that x equals plus or minus what? 5. Now that makes sense because if we were to factor this, wouldn't it factor to x plus 5 times x minus 5? Yeah, which is 5 and negative 5. How many solutions does this quadratic have? 2. Positive 5 and negative 5.
Do you have to have the thing, like, can it be x squared plus 25 equals 0? Or just, like, not do anything?
We'll see one like that in just a minute. Okay, look at 15. X squared minus 24 equals 0. So what are we going to do?
Add 24.
Okay, so I get x squared equals 24. I'm square root both sides. What do I have to add in? Plus or minus. So I get x, I'm going to get x equals, but what am I going to have to do? Yeah, let's simplify 24. 6 and 4. 2 and 3, 2 and 2. So I get x equals plus or minus 2 root 6. Radical and root are interchangeable. No, just like a shorthand for square root. Okay?
It's bad slang.
No, I mean, you can say it. All right, 2x squared minus 9 equals 0. What should I do first? Add 9. So I'm going to get 2x squared equals 9. Then what?
You have to divide by 2.
Yeah, you have to divide by 2 first. So x squared equals 9 halves. Now what do we do to both sides? Square root both sides. And I have to remember plus or minus. So I get x equals plus or minus the square root of 9 halves. We've got to keep going, though. This is not fully simplified. So let's go ahead and rewrite this. Okay, guys, hush, please. I'm going to go ahead and rewrite this as plus or minus the square root of 9 over the square root of 2. What is the square root of 9? So this is 3 over root 2. What do I have to do now? Okay, multiply the top and the bottom by root 2. So I get x equals plus or minus 3 root 2 over 2. Okay. Let's skip number 17 for now. Let's look at 18. X squared plus 16 equals 0. Hold on. Let's see why. Okay. Hang on. What's our first step?
Subtract 16.
Subtract 16. So we get x squared equals negative 16. So I square root both sides, and I get x equals plus or minus the square root of negative 16. Now, for real numbers, can we take the square root of negative 16?
No.
No. So for right now, what you say to this is that there are no real solutions. You have to put that word real in there because starting tomorrow or Monday, I can't remember, we're going to start talking about complex values. Okay? And complex values, okay, every quadratic has 0, 1, has two solutions. They just might not be two real solutions. They might be two complex solutions. Okay? Not fake, complex. Okay? Yes.
On the board where it says what we're doing today, what's this mean?
That C means complex numbers because on the syllabus it says that's what this is, but when we got closer, we noticed they don't introduce complex numbers till tomorrow. Okay? All right. Guys, your homework is out of the book. Okay? Listen to me for a second, though. Use your judgment about using your calculator. If you need to see, hey, listen. If you need to see if some number divides into it or what 288 over 8 is, use your calculator. That's fine. But if you come back with a simplifying radicals homework with all decimal answers, did you achieve the purpose of the assignment? No. So use your calculator wisely to help you if you need it, but don't cheat your way through the assignment. Okay? And remember that number